In this video, we're going to continue with the verification of more trigonometric identities. These will be a little bit more difficult than the ones we've had so far. Just a little bit. Still be using the fundamental theorems, or I should say the fundamental identities from trigonometry, along with, of course, some algebra, basic algebra. So let's look at the first one. I have 1 minus 2 cosine squared theta over sine theta cosine theta is equal to tangent of theta minus cotangent of theta. So I had mentioned before that normally you want to pick one side and show that it simplifies to the other side, whether it's the left side or the right side. Normally you pick the side that is more complicated or more complex and try to reduce it or simplify it to the other side. In some cases, it's not going to matter. The steps as you go through it will be very similar, but you always look ahead. So here, I wrote down the right side, tangent of theta minus cotangent of theta. So I'm looking at tangent of theta. I know that tangent of theta is sine over cosine of the angle. Cotangent is cosine over sine of the angle. So I have a cosine and a sine in the denominator. So I know when I combine fractions, I need a common denominator. So if I have a sine in the denominator and a cosine in the other denominator, it makes sense that the lowest common denominator will be sine theta cosine theta. So that's one of the reasons I picked the right side. So what I'll do here, now this is my objective right there. I want to get that from this right here. So I'm going to start over here, just to give me more space. So I'm going to write it out. So basically what I'm going to do now is try to combine this into one fraction. The right side is broken down into two terms. The left side is just one fraction. So here I look for a common denominator, which is going to be cosine times sine theta. Just basic algebra. Except we're using, instead of an x and a y, we have the functions sine and cosine. So this should equal 2. I'll put one division line. I'm going to write it as one fraction. So the common denominator will be sine theta times cosine theta, or cosine theta times sine theta. That's the same thing. So I'll write it as sine theta cosine. Now one thing I can do here is I can just cross multiply to get the numerator. So sine theta times sine theta is sine squared. Of theta. This will be minus, and the other side will be cosine theta times cosine theta. This will be cosine squared theta. So again, all I'm doing here is multiplying the first fraction here by sine, because I want it to have the same denominator, common denominator, sine theta, cosine theta. So it's missing a sine, so I multiply by sine here in the denominator, sine on top. So that gives me sine squared theta over this thing in the denominator, okay, the LCD. Then over here, this denominator in the second fraction is missing a cosine. So I multiply the numerator and denominator by cosine, so I can get a sine and a cosine in that denominator. That, of course, when I multiply it by cosine up here, it'll give me cosine squared. Okay, so where am I? I want to get this over here on the left side. I have a cosine squared there. I need a minus 2 cosine squared and a 1. But I know, again, your fundamental identities, the Pythagorean identities, that sine squared of the angle, in this case it's theta, plus cosine squared of the same angle, theta, is always equal to 1. So I can see that in the left side, on the numerator, I don't have any sine. I just have cosine. So that tells me that from this right here, and I did this in another identity, I can solve this for sine squared theta. Bringing the cosine squared over, I get 1 minus cosine squared theta. Okay, so that's going to replace this sine squared. So basically I'm taking this right here and replacing it right here. Just to save me my step here, all I'll do then is plug it in there and then combine. So what do I have then? I'm going to have 1 minus cosine squared theta and a minus cosine squared theta. So that's going to equal to 1. And then minus cosine squared, that'll give me a minus 2 cosine squared theta all over sine theta cosine theta. And that's the verification. Now this one will work either way. There's not that much more involved. If I were to go to the other side and take the 1 minus 2 cosine squared theta over sine of theta, cosine theta. Well, let me go ahead and clear this. That would be it. Again, if you're asked to verify or confirm or prove an identity, you just got to show that one side, either the left or the right, is or simplifies to the other side. But notice on this one here, let's say I started with the left side. Okay, I used the right side to verify the identity. If I start with the left side, how can I get this? Well, one way to do it is to realize that 1, as I showed a while ago, your fundamental identity, Pythagorean identity, 1 is equal to sine squared plus cosine squared. Okay, so replace the 1. I'm not gonna write it all out because I already did it one way, but this will guide you if you want to do it the other way. 1 is the same thing as sine squared. Replace the 1 by sine squared of the angle plus cosine squared of the angle, and then combine that. What do I get on top? Okay, I'm still going to get the sine squared of the angle. Okay, because I'm replacing 1 by sine squared plus cosine squared. And then cosine squared minus 2 cosine squared, that's minus cosine squared. Of the angle. And this is going to be over sine theta cosine theta. And then again, just to shorten the this particular part of the video here, then I'm just going to simplify. So the sine squared will be divided by sine of theta cosine of theta. So what's going to happen? One sine theta would divide out. So sine squared theta over sine theta cancels one sine, isn't it, with sine over cosine. But that is tangent of theta. Okay, so I'm not showing all the steps necessarily in this one because I already did it one way. And then the next one is, it'll be minus cosine squared over sine theta, sine of theta, cosine of theta. So we've got cosine squared and a cosine of theta. Cancels one of them. I'm left with a minus cosine theta over sine theta. But cosine theta over sine theta, that's your cotangent of theta. And that's what I want. Tangent of theta minus cotangent of theta. Okay, so this one I actually did both ways, but you just need to do it one way. Pick the right side or pick the left side and show how it simplifies to the other side. Okay, let's look at the next one. I want to show that the square of a sine theta plus b cosine theta plus the square of a cosine theta minus b sine theta is equal to a squared plus b squared. Now this looks like it might be complicated, but it's all basic algebra. So all we have to do here, obviously the best approach to take here is to take the left side. So that's why I already have the left side written out just to save a little bit of time here. And then I'm just going to do the squaring. All we're doing is squaring a binomial, if you want, kind of like x plus y squared. X plus y squared is x squared plus 2xy plus y squared. Or x minus y quantity squared is x squared minus 2xy plus y squared. Those are your formulas for squaring binomials. So in this one here then, I'm going to take this one first and say square it. Okay, so that would give me square the first term. That'll be a squared sine squared theta. And then it's a plus here. Twice the product of the a sine theta, b cosine theta. So that'll give me 2 AB sine theta cosine theta plus the square of the second term. So that'll give me a b squared. And then I also have to square the cosine squared theta. The other one is the same thing, squaring a binomial. Terms are a little bit different, but it's to square the first one. So I'm going to put it underneath. So that's going to be a plus. It'll be a squared cosine squared of theta. And then it's going to be, it has a minus, so it'll be minus twice the product of those terms. So minus 2. And then a and the b are going to be there. And then it's cosine theta sine of theta and then plus the second term squared, so that'll give me a b squared sine squared of theta. Okay. Now we just combine terms. So it appears to be kind of difficult at first, but all you really have to do is just perform the operation. You're squaring this binomial that is made up of sine and cosine, and then you're adding the square of this second binomial, which is made up of cosine and sine of the same angle. So let's look what we can simplify here. So look at this term here, 2ab sine theta cosine theta. And here I have a minus 2ab cosine theta sine theta. Okay, that's the same thing. The sine and the cosine are in a different order, but these are the same. So those add up to 0. Now, what do we have left? We have these two terms right here. A squared sine squared theta, a squared cosine squared theta, and over here b squared cosine squared theta, and b squared sine squared theta. So let's do this. From these two right here, we're going to factor in a squared. So I'm going to put it up here. You can see it. A squared. Factor out the a squared from those two terms, and what do I have in parentheses? I have then sine squared theta plus cosine squared theta. Okay, then we have the only two terms we have left is this one, b squared cosine squared theta, b squared sine squared theta. So I'm going to factor out the b squared from these two terms. And that'll leave me with cosine squared theta plus sine squared theta. And then this follows from that last step, so this is equal to this. And then of course I know from the fundamental identities, in this case the Pythagorean identity, we know that sine squared theta plus cosine squared theta, no matter what order it is equal to 1. So cosine squared theta plus sine squared theta, this is 1 and this is 1. Okay, that's one of your fundamental identities, so this then is going to equal 2. 1 times a squared, which is a squared, plus b squared times 1 is b squared, and that's what we're trying to show. We're trying to show that if we perform these operations on the expressions on the left side, we get the right side. So this is it. Now I actually had 4 identities in this particular video. I was going to have 4. The other 2 are even a little bit more involved than this, so I'm going to leave those for maybe part 2 of this. So I'm going to end the video here. Hope you understood these, and thanks for watching. We'll see you next time.